The same AI answer could one day cost one price now and another price tonight. Not because the machine became smarter, because Maya, opening her bakery before sunrise, was in a hurry. That sounds futuristic, but pieces of it already exist. Many people meet AI through a monthly subscription. Developers often pay a meter, so much for the words they send in, and another amount for the words the model sends back. Large companies can go further and reserve a lane of computing capacity for weeks or months. One technology already sold 3 different ways: membership, meter, and reservation. Here is a snapshot checked on July 22, 2026. Public Frontier model rate cards ranged from well under $1 to tens of dollars per million tokens, depending on the company, model, input, output, and service lane. OpenAI's GPT 5.6 Sol listed $5 for input and $30 for output. Anthropic's Opus 4.8 listed $5 and $25. Google's Gemini 3.5 Flash listed $1.50 and $9. Those numbers will change. More importantly, they are not a league table for intelligence. A token is a fragment of text, not a standard unit of usefulness, accuracy, or thought. Even the same model can charge differently for the same words. Imagine an archive. The first request brings an exact section of a thick company handbook to the desk. The next request can reopen that same prepared section instead of fetching it again. AI providers call this prompt caching. Reusing an identical prefix or repeated context can be much cheaper than fresh input, often for a limited time, although writing the cache may have its own price. The bill is beginning to measure not just how much you ask, but how much prepared context can be reused. Then there is time. Send a large, non-urgent job to a batch or flexible queue, and several providers advertise roughly half-price processing. Ask for faster or more predictable service, and priority or fast modes can cost substantially more. The model may be identical. What changes is your place in the queue. This is already the shape of an express lane. Cheaper if tomorrow is fine, expensive if every second matters. The queue is physical. Behind a chat box are scarce accelerators, memory, electric power, cooling equipment, network links, and software deciding which request runs next. When too many requests arrive, shared capacity can slow down or refuse work. The International Energy Agency estimated that data centers used about 415 terawatt-hours of electricity in 2024, roughly 1.5% of the world's total. AI is only part of that load, and the future estimate remains uncertain. But an answer on a screen has a real industrial footprint. Location matters too, though not always for the reason we imagine. Some providers add about 10% when customers require processing in a particular region, or only in the United States. That reflects a service and residency choice. It does not prove your prompt is cheaper wherever electricity happens to be cheap. Data centers must also consider available chips, grid connections, cooling, regulation, privacy, reliability, and the distance to the user. Geography is already on the invoice, but the full equation stays mostly behind the curtain. Cloud computing offers a clue to what could come next. Amazon and Google already sell spare virtual machines through spot markets, where prices can vary and the machine can be reclaimed when capacity tightens. Yet in the Frontier AI rate cards we reviewed, there was no universal price that rises at 6 in the evening and falls after midnight. Demand appears through queues and availability, while flexible AI usually has a fixed discount. So peak hour AI pricing is a realistic possibility, not a description of today's market. Back at the bakery, that distinction becomes useful. Maya needs tomorrow's production forecast before the doors open. That job is urgent, but hundreds of old invoices can be summarized overnight. The staff handbook can be cached because it rarely changes. If an AI service exposes these choices clearly, a small business could trade patience for price without understanding data center engineering. The smartest purchase might not be the smartest model. It might be the right lane for this particular task. Bigger users face another choice: rent each answer, reserve capacity, or own the hardware. Renting is simple when demand is uncertain. A reserved lane can make cost and speed predictable. Local servers may make sense when work is constant, private, and well-matched to a smaller model. But there is no magic break-even number. The honest calculation includes hardware, electricity, utilization, staff, maintenance, model updates, downtime, and the cost of answers that are not good enough. An idle machine can be more expensive than an expensive token. The token meter may also disappear from view. Customer service companies already offer prices per completed action, conversation, or resolved problem. Intercom, for example, publicly lists 99 cents for a successful AI outcome as defined by its billing rules. That does not make every outcome equal. The contract's definition matters, but it changes the sale. A business is no longer buying a bucket of text fragments. It is buying a contractually defined, successful resolution. From here, several futures are plausible. None is a forecast. First, subscriptions endure. A subscription offers one predictable bill, like streaming or office software. Providers could quietly balance heavy and light users, add limits at the edges, and buy compute in bulk. Intelligence would feel unlimited, even while a complicated meter kept running backstage. Second, AI develops clear service lanes. Saver returns a result by morning. Standard answers in a few minutes. Express responds now. A student preparing tomorrow's notes chooses Saver. A doctor looking up a drug interaction needs a carefully governed service with immediate, reliable capacity. Urgency becomes a choice, much like delivery speed, without pretending that every high-stakes decision should be delegated to a model. Third, truly flexible jobs follow spare capacity across time and place. A studio renders subtitles at night. The retailer postpones catalog descriptions until a region is quiet. Prices may respond to available compute, grid conditions, or congestion. That could improve utilization. It could also complicate privacy, data residency, reliability, and fairness. And a low electricity price is not automatically a low carbon signal. Any environmental claim would need the actual grid, hour, and data center, not a green label on a menu. Fourth, the cheapest cloud request is the one never sent. Phones and laptops already run some models on the device, with no per-call token fee. Private, repetitive, modest tasks could stay local, sorting notes, translating a phrase, searching personal files. Difficult questions, fresh world knowledge, or large workloads could move to the cloud. The trade is not simply free versus paid. Local AI shifts cost toward hardware and energy, while cloud AI sells access to scale and newer capability. Running a trained model to produce an answer is called inference, and access to a fixed measured performance level has become dramatically cheaper. Stanford's AI index measured a more than 280-fold fall in the cost of systems, reaching roughly the old GPT 3.5 benchmark between late 2022 and late 2024. That is a bounded historical measurement, not a promise that every capability will follow the same curve. Lower costs could spread useful tools. Pricing can also shape who waits, who receives reliable capacity, what stays private, and which work gets automated. AI may resemble electricity in its meter, cloud computing in its capacity, airlines in its urgency, and software in its subscriptions. It may never become only one of them. As Maya switches off the bakery lights, the deepest question is no longer just how much will an answer cost. It is, what exactly will the future meter reward?